Okay, so today we're going to continue our study of parametric equations, and we're going to go to page 122 and we'll do some applications. When you were in Algebra 2, you did projectile motion, and these formulas that we have on page 122 should look generally familiar, but you didn't have two of them, you only had one. So let's look at these formulas. We have x equals v naught cosine theta times time. And so, and we have y equals negative 1/2 gt squared plus v naught sine theta, all times time, plus h, and I'm going to put a little naught down here. So the subscript 0 means naught or initial, and v stands for velocity. So this is my initial velocity. This is the angle the ball or whatever was hit, launched, whatever. And this is t, which is going to be my time. So down here, this is my initial height. Sometimes you won't have one. This is my time, my angle, my initial velocity, my time again. It's just this g that we need to talk about for a second. This g is for gravity. And it's very important you read the word problem. If the word problem has feet in it, then we're going to use 32 feet per second squared. If the word problem's in meters, then we're going to use 9.8 meters per second squared. So it depends on what the word problem is measured in, which one of those two blue numbers you use. So let's go ahead and try this example. It says that Jim's going to hit a golf ball with an initial velocity of 100 feet. It should say per second, not section. So my v naught is going to be 150 feet per second. And I'm going to write down my g so I don't mess up. Because it's in feet, I'm going to use the 32 feet per second squared for gravity. And it says that my angle that it was launched at was 30 degrees. Since there's no initial height or h naught, we can assume it's 0. So these are what I call my givens. Things they tell me in the problem. I'm going to shrink those down for a second. And now we're going to start doing the questions. So let's see. Let's do some colors. So letter A says that I want to write the two parametric equations. So my x equation is going to be x equals 150 cosine 30 degrees times time. You could remember from the unit circle that cosine of 30 is root 3 over 2, or you could type it in your calculator. I'm going to leave it exact for now. Half of 150 is 75, so x equals 75 times root 3 t. So there's my x equation. My y equation, y equals negative 1/2. My g is going to be 32 t squared plus 150 sine of 30. Oops. There's a 1 in there, 150 degrees times t. And then I don't need a plus 0 at the end because my initial height was 0. So y equals half of 32 is negative 16 t squared plus sine of 30 is a half. So half of 150 is 75, and then my t. So there is my other equation. So there's part A. So there's my part A. Okay, let's do part B. Part B says, oh, I didn't mean to grab a highlighter. Let's try that again. Part B says that, how long is the golf ball in the air? Okay, well, talking about up and down in the air is a y thing, a vertical thing, so we're going to use the y equation. And I'm going to say that y equals 0. Because if the ball's on the ground, it's not in the air. So y equals negative 16 t squared plus 75 t. And when there's no initial height, this problem becomes a lot easier. So they both have a t in them. So I'm going to pull a t out. And then you get negative 16t plus 75. And this still equals 0. And now we can set each piece equal to 0. We can use the 0 product property. So 0 equals t, and 0 equals the negative 16t plus 75. This t equals 0 is when the ball starts. That doesn't tell me how long it was in the air. At time 0, the ball was on the ground. But I need to find the other part. So I'm going to subtract the 75 over, and then you divide by a negative 16 to find your t. Just grab a calculator. A negative divided by a negative is going to be a positive. 75 divided by 16 is approximately 4.688 seconds. Remember, story problems have story answers, so the ball's in the air approximately 4.688 seconds. So there's part B. Let's do part C. So part C says that it wants to know what is the maximum height. So let's think logically for a second. So this shape is a parabola. This is time 0. Ball goes up, it comes down. It comes down over here, we just proved in the last part, at 4.688 seconds. So that means halfway in between those two times must be the maximum height. So you're going to take your time that you were in the air, and you're going to divide it by 2. And so that means that my maximum height happens at 2.344 seconds. So now I can take that and plug it into my y, because my y is a height thing. So y equals negative 16, 2.344 squared plus 75 times 2.344. And I'm just going to type that in my calculator. Make my life nice and easy. So negative 16 times 2.344 squared plus my 75 times my 2.344. So the maximum height the golf ball hits is 87.891 feet. Remember, again, story problems have story answers. So there's my maximum height. Oops. So there's part C. Part D says determine the horizontal distance the ball traveled. So the horizontal distance the ball traveled is based on the time, how long the ball is physically in the air. So the ball, for letter D, the ball's in the air a total of 4.688 seconds. So to find the horizontal distance, you're going to use your x equation, because x is what we use for horizontal. And you're going to do the 75 root 3 times your 4.688. So 75 times square root of 3 times 4.688. So the horizontal distance is 608.989 feet. So we got A, B, C done. Letter E says, simulate this in a graphing calculator. So let's make that happen real quick. So here's my calculator. I'm going to go home and I'm going to pick a new document. I'm not going to save. So I'm going to go home, new document, and I'm not going to save. I'm going to add a graph. Here's the trick. When you get in here, this still says y equals. So what we're going to do is we're going to press menu, and we're going to pick graph entry edit, and we're going to pick parametric. And when you do that, there's your equations, your x and your y that show up. So I'm going to type my x equation, and my x equation was... I had the exact value, 75 square root of 3 times my, make sure you type a t when you do it, your time. And then my y equation was negative 16 t squared plus 75 t. Down at the bottom down here, this t step is the time. Oops. It's the time, it's the increments. It always is going to default from 0 to 6.28 because 6.28 is 2 pi, and you're going to find out on Monday that there's a 2 pi thing that goes on in these problems, but I don't want to ruin it for Monday, so we'll just wait. But the time that we had in our problem was 4.688 seconds, so we should be okay. But we are going to have an issue with the window because it's not going to be high enough. But let's press enter and we can deal with the zoom on the back end. So you see something kind of happen, and you can do menu, window zoom, and you can do fit, or you can play with the window yourself. But when you do fit, there's your pretty parabola. And so it's showing us there's our horizontal distance, the 600 and something that we had. The top distance up here, if we go grab your axis, falls in that number that we got. So you simulated it on a calculator. Now you've completed part E as well. Okay, so let's do one more of these problems, and I want to do one where the initial height is not 0. So on Canvas, your homework or your submission for this part of the week, there's a worksheet that has 10 problems, and number 2 was not assigned to you, so I'm going to do number 2 from that paper. So number 2 says that a cannonball is fired across a flat field at an angle of 64 degrees with an initial speed of 90 feet per second. I'm going to write down my gravity. I'm going to use the 32 feet per second squared because we're in feet. And this one has an initial height. My initial height is 37. So we're going to do the same things again. It says letter A, write your parametric equations. So shrink that stuff down. Oops. So letter A is going to be x equals 90 cosine 64 degrees times time. On this one, you're going to have to use your calculator. Please, I have told you this many times, pay attention to degrees and radians. Either put your calculator in degrees, or I'm gonna type the degree symbol on mine. So 90 times cosine 64, and I'm going to insert my degree symbol. So my x equation is going to be approximately 39.453 t. My y equation is going to be negative 1/2 times g, which is 32 t squared, plus 90 sine 64 degrees times t, plus my 37, because I hit initial height. This piece I'm going to type in the calculator. And then we're going to get y equals negative 16 t squared plus approximately 80.892 t plus 37. So there's my other equation. So there's letter A. Letter B says determine how long the ball's in the air. So this is where the work comes in. I'm going to say 0 equals negative 16 t squared plus 80.892 t plus 37. We're going to go way back to algebra 1. I don't want to factor this. I don't even want to try. It's not worth it. It's got decimals. Yuck, 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 yuck. We can complete the square. I don't really want to do that. I'm just going to go back to the quadratic formula. So here's my A, my B, and my C. So x equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. I'm going to type this in my calculator, like just one big equation. So I typed control divide, so I have a fraction. Negative 80.892. I'm going to do the plus version first. One of these should be very close to 0. So plus square root 80.892 squared minus 4 times negative 16 times 37 all over negative 32. Well, this is the one that's really close to 0. So you can arrow up and highlight your equation, or you can type it all over again. And I'm going to do the same equation, but let's type the minus version and see what happens. There we go. It says that x, which in this case really is my time, because that was the thing that I had, the variable in the equation, and t is going to equal 5.478 seconds. So that's how long the ball's in the air. I'll leave this one down here. It's a little bit bigger. Letter C says determine how far the ball traveled. So that means its horizontal distance, side to side. How long did it travel? So for letter C, x equals my horizontal 39.453 times my total time, my 5.478. So my total distance traveled was 216.12 feet. Letter, I shouldn't even be calling them A, B, C, 1, 2, 3. Number 4 says determine when it reached its maximum height. Well, that one's not super hard. So letter D and E, or 4 and 5, go together. T equals 5.478 is my total time. In the last problem, I talked about how you divide this by 2 to find the middle so you can find the maximum. So it hits the maximum at 2.739 seconds. And then letter E, or Roman numeral 5, it says determine the maximum height. So y equals negative 16. 2.739 squared plus 80.892 times my 2.739 plus, sorry, I'm running out of room, plus 37. So I'm just going to type that in the calculator. Negative 16 times 2.739 squared plus 80.892 times 2.739 plus 37. So my maximum height is 138.529 feet. So now that you're a pro at doing these word problems, you can go back to Canvas and do a couple and submit them.